We are all used to thinking of past as being definite. In this video, I'll be revising the notion of past and how, just like the future, it exists a spectrum of possibilities. But first, let's dive a little into one of the fundamental concepts of quantum mechanics known as wave-particle duality. It is best demonstrated through a double-slit experiment. Quantum entities, say electrons, are sent one by one from point A to point B, passing through a wall containing two thin slits in it. If we decide to monitor the electron's path, they seemingly pass through either one slit or the other, acting like particles. Conversely, if we don't observe the path, each electron passes through both slits simultaneously. It overlaps with itself as waves do in the ocean, producing a pattern known as interference. To explain this strange behavior, Richard Feynman came up with a fascinating realization. He formulated a view where a particle is said to take every possible way to travel from point A to point B. At point B, the quantity associated with each of these different paths gets combined. This leads to interference pattern as the combined quantity is at its maximum or minimum depending on the location of B. Now, if we observe the electron at either of these two slits, we eliminate all the rest of the path that it travels through. This ensures the particle-like behavior of the electron since it won't be interfering with itself. Feynman showed that our observation of an electron at point B is constructed from all of the possible paths that the electron could have taken to come to this point. Because of that, his view is referred to as alternative histories formulation of quantum mechanics. And it has important implications for our notion of the past. It turns out that no matter how precise our observation of the present is, the unobserved past, just like the future, exists as a spectrum of possibilities. Feynman's view can be applied to the universe as a whole. If you go far enough back in time, the early universe was so small that the effects of quantum theory had to be taken into account. However, one problem that seemingly arises is when we ask ourselves about the beginning of time. After all, something must have set it going. The solution to this problem came in 1983 through the work of Stephen Hawking and James Hoddle. They solved the problem of the beginning of time just like we solved the problem of the edge of the world. If we think of the South Pole as the beginning of the universe, then to ask what happened before the beginning is like asking what's further south than the South Pole. Our intuitive understanding of the past consists of a series of definite events. We tend to think of the past as being single, thus taking bottom-up approach. But we must take into account the quantum origin of the universe and apply Feynman's alternative histories formulation to the universe as a whole. Thus, we should trace all of the possible histories from point B, our currently observable universe, to point A, Hawking-Hoddle state, and take top-down approach. These histories don't exist independently of each other, but depend on the conditions of the universe that we observe today. In the words of Stephen Hawking, we create history by observation rather than history creating us.